Okay, hopefully I am live now. I'm gonna wait for a few seconds. Hello, welcome back to the stream. Okay, let me do something. Okay, cool. So today I know I said 7702. We're gonna work on that standard, but for now I'm not gonna work on that. I'll change the title. I'm still working on 4337, and right now I'm working on this part, uh, the signature aggregator. Finally, I figured out how this works. The BLS signatures. I'll show you one repo that that will like clarify everything. And just a second. Let me tweet like that I'm live. Okay, cool. So I was saying, let me show you this repo. This is my repo where you can see how that thing is working. Hopefully you guys can see everything correctly. uh, we were working on simple account contract, paymaster, account factory. I think we worked on all of these things, but I don't remember the details. If you want to see all these repos, you can go to uh, my profile. You know where, you know, this like github.com/my username, and you can find all of these. Here we are, um, sorry, here is a BLS signature verification contract. All these things, I'll do another stream on what these things are, like what negated generator is, G1 point, G2 point, hash signatures, all those things. Only thing you need to think about right now is verify signature. So you need to know like what this is, because we are going to use this in our signature aggregator. So to verify this signature, any BLS signature, like if it's a single signature, I'm saying any single non-aggregated. When I say single non-aggregated signature, we need negated G1 generator public key and sorry, we need negated G1 generator public key signature and hash of the message. So and that is converted to G2 point. What G2 point is just a point on a graph, 2D graph. So G1 is 1 point, G2 is 1 point, and we are passing those arrays. So G1 points is array of 2 elements of type BLS dot G1 point, and G2 points is same, BLS dot G2 points, and we are passing this here in the in this function BLS dot pairing, And for aggregated signature, we are doing the same. Just one thing is, sorry, this is very well. Okay, this is different. I just overloaded this function with instead of bytes messages, I'm just taking G2 point. For aggregated signature, we need all the messages, all the pub keys, and the aggregated signature. Before that, this signature was just single signature, non-aggregated, and this one will be aggregated one. So we have this. We need to check array length is same for messages and public keys. It just that's what we are checking here. Then we are creating G1 points and G2 points array of length, whatever the length of messages array is +1, because we need to pass negated G1 generator and aggregated signature there. G1 points will pass all the pub keys, G2 points will pass all the messages converted to G2 points, and at the end we are passing negated generator and aggregated signature. And same BLS dot pairing, we are passing those array and it's verifying that. That's the gist of it. You can check it here. It's fourth one, and currently I'm working on this fifth project, which is signature aggregator, work in progress. Like you can see whatever it is here, whatever readme is here right now. It's just like clone it and run the coverage. Okay, let's get back to the contract that I'm working on right now. So ignore this part. This is what we are going to work on right now, and run that command, which is forge coverage dash odyssey, and hopefully we'll see like 100%. Yes, we have 100% coverage. BLS account is similar to simple account, as just few extra things, where if we go to, where was this? Yeah, if you go to ERC-7766, let me check. EIPs 7766. Sorry about this. Okay. 7766 signature aggregation. No, I think it's here only. Signature or aggregators, it should be somewhere here. Let me search agree. Okay, no, it's here only. So it tells you what, yeah, and on this line, account signifies it uses signature aggregation by returning its address from valid user of function. So that's what I'm doing here, where I'm just packing. I'm taking the address of aggregator in the constructor, storing it in the global variable, then packing the validation data. So if you remember, validation data was a combination of three things, which was aggregator, timestamp, valid after, and valid until. Those two timestamp of uint 48, and address is always uint 160. If you convert to uint from address, it will be uint 160. in our simple account we were just doing signature like pass or fail. We didn't pass any values like valid and until valid after. So at that point we just needed like if it's correct or not, so 1 or 0, but we also had option to pass address of the aggregator. So that's what we are doing here. I just created this data object, then passed it here. Okay, I also don't need this line. I can just, yeah, and it should work the same. Then public key, yeah. Entry point we already know. This one is new, where BLS public key is G1 point, as I said, and we are taking that in the constructor and storing it, and this is just a view function, and this is our simple thing. We also need to implement this. Maybe I'll just do that right now. Internal view, public view. Okay, let's cut this. I don't remember the like styling like how it should be structured, but what was that? Okay, I wanted to do something and I forgot. Okay, here we also need the owner, address of the owner. So let's install OpenZeppelin and then get the owner. So I'll go to $133 soldier.xyz. Okay, maybe when I did the streams 1 month before, like in January, I wasn't using soldier. I was just using GitHub submodules. So you might not know what this is, but you can just check Foundry documentation to understand and see how this thing works. Soldier, Foundry, soldier solidity. Okay, Foundry docs. Then there should be 133 soldier. Yes, you can follow these commands and install it. I was just gonna search same thing here, the OpenZeppelin package. You can copy this command and run it. Okay, it's already installed, and we need to import ownable. OpenZeppelin access ownable @open Zeppelin /contract/access ownable.sol. Okay, we have that. Now we is ownable underscore owner. address owner. Okay, maybe I can just use BLS signature also here, where the owner can sign with BLS public key, private key, and we can check that signature, where message will be something like hash change the public key to hash of public key, and then hash will be here, and hash will be basically kcalc256 abi.encode bls.g1 point, something like this. But for now I want to keep this simple, so public view, internal view, here function change public key or change pub key public only owner then function change aggregator public key only owner. Okay, here we are gonna take bls.g1 point new pub key s underscore pub key equal to new pub key. Okay, call data done. Address owner, no, aggregator, we're gonna say s underscore aggregator equal to new aggregator. Okay, this is done. We should create two events for that. Event pub key change. Okay, I want to see one of the dependencies, infinitism contracts samples BLS account, and they are doing something. Okay, it's coming from IBLS account. Okay, they are just passing those two values. Yeah, that also works, but I don't really mind. Ours will be different because we are using different library. Old pub key bls.g2 point, no, g1 point new pub key. Okay, we should also pub key changed, then aggregator changed, address old old aggregator address new aggregator. Done. Emit pub key changed, and it'll be s underscore pub key and new pub key. Okay, this is done. Then aggregator. Okay, emit aggregator changed, s underscore aggregator comma new aggregator. Okay, this is done. We need to add those two things also. What happened here? Oh, we need address of the owner now. Owner done. There should be, yes, another issue. We are gonna test change pub key event and access public we have how we are generating. Okay, we are generating create pub key. We have one, so let's say bls dot g 1 point new pub key equal to memory. Now we need to do bls account dot change pub key and new pub key. Okay, what? Okay, s underscore bls account. We are gonna say vm dot prank. No, vm dot expect revert with abi dot encode with I want to check what is the error with only owner. Wrong ownable. This is the error. Also, we didn't actually check like how much we had a less coverage, right? So how much coverage is decreased? That's what we want to check. So you can see all these things are there. We went from 100 to 66, and now we want to get back to 100. encode with selector. What happened? Okay, at least one. Cool. Enable dot. No. Dot selector. And then say address this. Why? Because when we are calling this function, we are calling from this contract instead of owner. vm.prank s_owner. Okay, that's done. We also need to do BLS. No, expect emit. vm.expect emit false, 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 true. Address s_BLS account. Then emit BLS account dot pub key changed. We'll say s underscore pub key. We are not saving the public key. s_BLS account dot get pub key, and then new pub key. So we are saying we are expecting an event. There are no indexed parameters. We can have 3 index parameters, right? So false, false, false. This is true because we know all values of all the non-indexed parameters and where the event will be emitted from. So this is where the event will be emitted from. Let's see, hopefully it will run correctly. Oh, no, it didn't. Let's see where I messed up. Okay, if you see this error, G1 MSM failed, remember you need to add the another flag, which is a dash odyssey, which is alpha network. What? Change pub key. This worked properly. Emit this. Okay, wrong. We are doing vm.prank. Then why it's not working? Okay, we messed up big time. Not big time, but we messed up somewhere. Why the count is that? In the setup, we are passing the owner. new owner, ownership transferred from this to this. Cool, that's understandable. Sender creator, whatever. Entry point, white code. S underscore owner. Okay, prank is working properly. Okay, let's run again and see if we get the same error. We are getting the same error. Now we need to check why. Okay, let's just remove this. It's correct. Okay, we know this part is the issue. Sorry, this particular part. Okay, let's go down, format it. We are doing vm.prank s underscore owner, and it's still not working properly for some reason. Okay, this is just messed up. Why the prank call was not getting who knows. The prank call was not getting, I don't know. Prank was getting called, but for some reason when I did this call it was not happening. Maybe because of line 97, because prank does the next call. Prank changes the caller of the next call. So maybe this is the next call. That's how the foundry is interpreting it, and this is not. Sorry, this is the next call, and this is not. So that's why it wasn't picking up the prank as the s underscore owner as the actual owner, actual caller. Okay. Odyssey, yes. Still 81. Okay, same. We are doing the same thing. Function test change aggregator event and access public. No, we want address new aggregator equal to MAC address. We have the new aggregator. Now we'll say vm.x expect emit false true address s underscore BLS account, then emit BLS account dot aggregator changed right now we don't have any function to get the aggregator, right? Yeah, well then we need that function also. Aggregator s underscore aggregator address. Done. S underscore BLS account dot get aggregator comma new aggregator vm dot prank what this will be s underscore owner s underscore BLS account dot change aggregator new aggregator. Okay, so this is the first one. Then vm dot expect revert abi dot encode with selector ownable unauthorized dot selector comma address this s underscore BLS account change aggregator new aggregator. Oh no, what's happening here? Okay, is there a spelling mistake? NEWAGG. Okay, yes, there is a spelling mistake. Okay, so if there is a spelling mistake, then okay, anyway, let's run the coverage. 100%. Cool. We have done this part. Let me okay, now we can go to the aggregator, writing actual this thing. Before that, we need to check the EIP or ERC. iAggregator contains has these three functions that we need to implement, which is validate user of signature. It will check the BLS signature if it's correct or not. Then next is aggregate signature. With this we are just gonna aggregate the signatures like with bls.add. That function is there. I think I showed you with in here. So no, I didn't show you. If you go to test and down to test contract verifies aggregate signature, you'll see I am aggregating signatures here. So if you add all the G2 points, so all the signatures from here it's array. In our aggregator it will be array of user operations. So we'll take all those signatures and add it. It will generate one single signature, which is aggregate signature basically, and we can return that. Then ERC, yeah, aggregate signature, and validate signature is same thing that we are doing in this function, where we'll do this part. Not this exactly. Let's go to the actual contract. We'll do this this part where we have messages, we have public keys, we have aggregate signature. So combine all those things and just show it. Let's view external and sig. So here we will fail, will revert if the function doesn't work. Sorry, will revert if there is any error or verification fails, the validation fails. Here there is no need. If there is need, will revert with correct error, but return value is there. So why return value is not there? That's what I was trying to explain. Where if there is an issue, we need to revert and give a correct error. Same here. Sig for user op, we will just return empty bytes. We don't need anything in that scenario. So let's read these steps, like how handle aggregated ops. What's the name? Yeah, handle aggregated ops function will execute all these things. So an account signifies it uses signature aggregation by returning its address from valid user op. That we did in BLS account.sol, in that contract. During simulate validation, this aggregator is returned to bundler as part of aggregator info field. Part of aggregator info field in validation result struct. So if you go to entry point simulation, I think you'll see these things. It's just returning the address to the bundler. All aggregators must be staked. Okay, that's the rule. We know that. Bundler should verify aggregator is not throttled or banned according to 7562 rules. It's just those are rules for DOS attack or DDoS attack, something like that. You can read those rules. It's not on chain, so it doesn't matter for us. It's for the teams who are implementing the bundler, not the contracts. To accept the user, so we need to understand those rules, but for the objective of this stream, or for this stream, we don't need to understand those. We just need to understand that our aggregator, when we are doing anything, it should be staked. It won't be checked on chain, but it should be staked. To accept the user operation, the bundler must call validate user op signature to validate the user operation signature. This method returns alternate signature that should be used during bundling. An alternate signature is normally an empty byte array, but it can also contain some data for the account. the bundler must call validate user op a second time on the account with user operation using returned alternate signature and make sure it returns the same value. Okay, the bundler is calling that thing 2 times. Let me go back to this contract. In any case, we are just returning this value, right? Okay. I want to check how each infinitism team has implemented it. Samples BLS account. This init part is just BLS signature. We can ignore it. Yeah, they are also doing the same. Go back to browser. We are reading this point. Now this implementations of aggregate signatures function must aggregate all user op signatures into a single value. Note that the above methods are helper methods for bundler. Bundler may use native libraries to perform the same validation and aggregation logic. Okay. Implementations of validate signatures function must verify aggregated signatures validity for all user operations in array and revert otherwise. This method is called onChain by handle aggregated ops. Okay, as I said, last part is only done on chain, rest are just off chain helpers. I'm confused about one thing where this part, if we see, does this implement validate signatures? Yes, it does, and is doing the same. Pub keys, okay. Internal user operation hash, was the next part. User op hash, validate signature, okay. This method is called after entry point simulation, returns an aggregator. One thing that I want to know is, okay, so there will be two times. One thing is called this validate user op is being called 2 times. Once with the actual signature, once with the empty signature, like the empty bytes value. I don't know why they are doing that. Maybe because validate user op has this weird function where it can return some data, but I don't know what that use case might be. That's why I'm confused. Where that use case shouldn't be there for some reason, because I can't see that reason. And yeah, that's the only thing. Like why should the contract function should return some data for that particular contract, because it's getting called twice. You can see the bundler must call validate user op a second time on the contract with user operation using returned alternative signature, and make sure it returns the same value. That's weird. That's why this part is there, contains some data. If alternate signature returns some data, then validate user op should get a chance to validate the signature again. Maybe that's why they are calling it twice. But when the handle aggregated user ops is called, the aggregated each user op in that array, like we are gonna pass array to this function, user operations array. All those user operations will have the original signature, not the alternative signature. That's my interpretation. If I'm wrong, I don't know. Performs same logic, transfers each. Okay, we'll see, like, if I'm wrong, but most probably I'm not. Okay, VS Code. Back to VS Code. BLS account aggregator. I think we have 7 minutes. Let's see how much we can implement quickly. Contract aggregator is I aggregator. We need to implement 3 functions. Which is one. Okay, sorry. We also need to import this. Oh no. Done. Next is validate user op signature. Here is where we are gonna check the user op signature and return the empty bytes, I think. In the BLS account, no, in the signature aggregator, we can see that we are verifying the single signature. If it's wrong, we are reverting. If it's right, we are returning empty bytes. We can just say next. Sorry, what's the next part? This. Return okay, don't return anything, we can ignore it for now. first thing first, validate signatures. This should be last, not the first function. Here we are gonna use verify single, like we have done. Oh no, we haven't done it here. We also need BLS this import BLS from solid. Next, BLS.g1 point g1 points. This will be array memory equal to BLS.g1 point no sorry array of 2 just give me a second. I think it's here somewhere. Oh, I'm doing everything right. Just the part is new. What's up with this? G2 point G2 G2 G2, that's done. Why I'm messing up this? Yeah, now it's correct. Cool. Next part is getting the hash. Can we can just import the BLS account here. BLS account source / BLS account dot sol. Next, we need bytes 32. I had something else in mind. I wanted to get the hash. For hash we don't need this. Okay. We also need the entry point then. For entry point core / entry point. Now my idea was bytes 32 user operation hash equal to entry point dot get user operation hash user op, and then pass user op BLS account user op dot sender dot entry point. So we don't need entry point here. Okay, so what I did here, basically called the BLS account. It already had the entry point, and from that entry point I got that hash. We also need the negated G1 generator. This is calculated off chain. It's same for everything. Now BLS dot G2 point memory HM BLS dot hash to G2 user operation hash. Why? Really, I don't trust it. I don't trust that BLS solid source utils etc. BLS hash to G2 bytes. Okay, can we call I entry point? Does it have a function to encode? No, it doesn't. Is it in the helpers? Core helpers encode? No, it's not. Encode. User op has a hash function. So packed user operation. No, user operation lib. It has a encode function. Okay. We need to import this. Okay, I'm gonna write this function, complete this, and I'm gonna end the stream. We'll deep dive into rest of the things tomorrow. Core lib using for packed user operation, which will be, we don't need this. User op dot encode. That worked. We have the signature, we have the G1 generator, we have the public key. Let's start assigning things. Points 0. First element will be negated G1 generator. Then second point will be public key. We have user op, BLS account, user op, sender dot get pub key. G2 points 0 equal to so we haven't created a function to convert bytes. The signature is in bytes, it's not in G2 format. Okay, this will be signature, and next will be HM. Okay, ABI dot decode user op dot signature and pass it the tuple of BLS dot G2 point. Okay, next is require BLS dot pairing G1 points, G2 points, sig verification failed. Okay, let's see. For now, that's it for now. Tomorrow we'll see if this actually works or not by actually writing the test and checking out everything. Let's run the Odyssey coverage. Hopefully there are no errors. Okay, we know we haven't written any tests, so coverage is 0. Another coverage is 100%. Cool. Let me add get commit -m account improved tests and aggregator. Just a second. Aggregator skeleton. Okay, so basically like it's a bare bones, so that's why I wanted to put skeleton there. Skeleton get push okay, cool. I think that's it for today's stream. Hopefully you like the stream, and see you guys tomorrow.